Hi, welcome back to the workbench. Today we're doing a bit of citizen science to see why the PLA, or at least doing some experiments to try and see why PLA might be breaking. There's some question the last time I did this on whether PTFE tubing played a role. So I've got a couple different types here. There's a very wide PTFE tubing that'll help hold it straight. There's also one we can wrap around the spool to see if on its own, if it's doing anything. This has also got about a 1.8 millimeter interior diameter, so it'll be fairly tight around the PLA as well, which provides a contrast to this. We'll also hold PLA straight on its own, and we'll leave some wrapped around the roll to see what that does. I'm not sure what any of the results are going to be, and I might have to perform the experiment a few times, so we might have a longer time frame as well as the short couple days I'm going to do this for on this, just to see how it'll work on the workbench. I'll go stage it in a more appropriate area if I need to do it over a longer period, say a couple days, a week, a month for controls. And we'll see how it works. I'm not sure at all what is going to happen on this one, so let's stage it quick, and then we'll pause for some number of days, come back and see what we got. Now, if you enjoy these videos, please give us a thumbs up down below and think of subscribing. Thanks. So this all came about when somebody was wondering if the PTFE tubing was playing any role in the PLA breaking from my last video. I don't think it was, but who knows? I couldn't think of any mechanism by which that would happen. Maybe some kind of moisture ingress or something. But I figured it was worth actually running a couple of experiments and seeing if there was anything going on there. The first part, the mechanical stressing on the PLA itself, is what's happening when you unspool it, essentially. So if you'll notice, even when I unspool it from the reel, it still wraps around in a circle. Now, when I hold it straight like this, that's causing a stress on the plastic. PLA in particular is a little brittle, and it's thermally formed, so when you stress it like that over time, it does tend to break. That's what I was seeing on at least some of the examples I had last time, because they were in a box with desiccant, and there wasn't much else going on except for them being skewed oddly as they were sitting in there with their ends wrapped through a roll like that to prevent them from kinking all over the place and messing up when I took them out. So what we're going to do here is force this through the PTFE tube for one of our examples. Toward the center there, it's going to force that to be straight-ish, and then the rest of it's going to be curled as usual. This one is, I think, going to wrap around the spool like this. Actually, let me get a bit of a longer piece off here before we do that. All right, put that aside. This one's going to actually wrap around the spool, and then we'll just tape this into place on the spool so that it doesn't get messed up while it's sitting there. So this is just going to be a narrow PTFE tube example. It's going to cut through. I'll pull it through a little bit. And we're going to wrap it as it would be on the spool. And then we'll tape the end down. Okay, going to use some duct tape. Hopefully that'll stick a little better. Let's see. All right, that's, as you can see, still fairly tightly wound. Hopefully the tape adheres for long enough to get the job done. And we'll leave that sitting aside. This one, let's see, do we have two lengths? Nah, that one can sit aside. That'll be our control. This one's going to be straightened over the length. And I'll need something to weight down both sides. There we go, the bench vices. Those will definitely hold that down. So now we've got it set up. We've got a control. We've got some straight through PTFE. We've got some rolled in PTFE and, well, rolled around the spool in general. And then we've got one piece just held relatively straight by a couple of vices sitting on it. If I can get that again. Hopefully I didn't just mess this up. There we go. Nope, that's not straight at all. Whenever I can get this back. Alright, now using the vices for their intended purposes, I'm pulling this straight, although I probably want to release a little bit of tension on that to better mimic what you'd usually find. Alright, there's a little bit of tension on that, but it's not pulling it taut. Although, would it be taut? That's a good question. So when it's being pulled into the filament extruder, that's going to be the motor, pushing it up through there. I'm assuming there isn't going to be a little bit of tension, but not as tight as a couple of vices pulling it taut. So I think that's probably about right. So we'll leave that like that. We'll leave this through the PTFE, this one through the PTFE, and our control just sitting out. And let's see what that gets us. I'm going to leave this overnight, and we'll check back with it tomorrow and see if anything interesting happened. If that doesn't work, then I will set up the experiment somewhere else for a week, see how it goes then. If that doesn't work, I'll set it up for a month, see how it goes then. I'm really curious what's going to happen with this. All right, well, I will see you shortly, and we'll check on how it's doing. It's now a couple days later on my workbench, and the results are in. As you can see, the stresses on the plastic have caused it to snap. After only a couple of days on there, it's become brittle, as you can see, without the aid of anything else except for, well, there you go, just broke again. Without the aid of anything aside from being held straight between these two vices. That's what I'm referring to when I state that it's mechanical stress when you hold something straight that's been heat formed around a wrapped spool, PLA specifically. That isn't true for all plastics. That isn't true for all cases. It's just PLA does that when you hold it straight, and that's what I was showing in the video previously. As you can see, the part that was held straight in a piece of PLA here, also a bit brittle on the, it looks like it was only a bit brittle on the part that was held perfectly straight. And let's check out our PLA coated sample. Let's see, first off, did it actually, okay, it unwound itself a little bit, but that should be okay. Let's see what we get here. I also managed to get goop all over some of the PLA. That's probably not going to do me any favors, but that's okay. It's in the interest of science. Okay, here we go. So let's unspool. That was held a little odd. But as you can see, just being in the PLA alone didn't really do too much to our filament. This stuff's still fairly pliable. It's not snapping easily, as you'd expect if there was some problem with just being held in the inexpensive PLA that I've been using for the test. That's not anything special. It's just standard brand PLA off of, supply website. And that's it. So that's what I mean when I said mechanical stress in the previous video. What I was referring to is the act of holding it physically straight after it's been thermally formed. It stresses the plastic, causing it to break after it's sitting in that position for a bit of time. And, well, actually, hold on. Yep. This was our test sample that was the, what do you call that, an experiment, the control. So this was just sitting there on its own without being treated in any special way, just cut off the roll, allowed to sit on its own without anything applied to it or bending or anything like that, and it just held up okay. This is the piece that was in the vise, and it snaps all over the place because it's been stressed. And that's it. There you go. Hope you learned something today, and thanks for watching. We'll see you next time.